So here we're doing a different kind of problem where we're asking whether or not, whether there's a birthday effect for men's college baseball. So the following data show the birth month of current college baseball players when the cutoff day for determining age was August 1st. So for example, a male born in August would be the oldest for that age group. The idea behind this problem came from the book called Outliers by a sociologist named Malcolm Gladwell, where he looked at birth months of players in the National Hockey League. And so I decided, hey, I'm going to check to see if that applies to baseball. So think about it this way. If you're 10 years old and born in August, you would be almost a year older than a player born in July. And you can think about it as a 10-year-old, what a big difference that is. That's almost 10% of life, right? And so the question we ask is, if you're older on a given baseball team, do you have a better chance of being a college baseball player? Here, we're asking, does the data suggest that birth month is not equally distributed across the 12 months? So our assumption is, yeah, they are equally distributed. So our null hypothesis in this problem is the proportion of college baseball players born in January is the same as the proportion born in February, is the same as the proportion born in March, is the same as the proportion born in December. And that proportion would be 1/12 versus birth month is not equally distributed. We're agreeing to use the 0.05 level of significance here. And now we're going to go ahead and get our p-value from StatCrunch. So here I'm not giving you a distribution because the distribution is equally distributed across in this case, the 12 different categories. So let's go to StatCrunch again. I went ahead and entered this data in as well. So all I did is enter in the number of players for every given month. So 96 is the number of players born in January, 74 is the number of players born in February, etc. So I don't even have to enter a probability distribution here. All I have to do is go stat, goodness of fit, chi-square test. The observed column is the players. And then the expected column, all I have to do is check the box that says all cells in equal proportion. We're going to get the expected values, click compute, and there's our result. So notice the expected is 82.25. Where does the 82.25 come from? It comes from the 987, which is n times 1/12, or 987 divided by 12. So if birth month is equally distributed across all 12, you'd expect 82 players to be born in January in college baseball, 82 players to be born in February in college baseball, etc. There is your test statistic, 27.77, and there's your p-value, 0.0035. And so if birth month was equally distributed, we'd expect to see results similar to what we've seen in about 3 or 4 of every 1,000 times we did this study. So let me jot down the interpretation of this p-value. If birth month is equally distributed in college baseball, we would expect to observe results such as those observed in about 3 or 4 of every 1,000 repetitions of this study. And that comes from the fact that 0.0035 is between 3 out of 1,000 and 4 out of 1,000, right?
Mm-hmm.
Right, so our p-value is certainly low, and therefore our null must go. And so here we're going to say there is sufficient evidence to suggest the birth month of college baseball players is not equally distributed across the months. And in fact, you can compare what you observed to what you expected to see why this is happening, right? So for example, this is, let's see, so this is December, November. This month right here is October. Look at how many more college baseball players were born in October than you would have expected.
Mm-hmm.
Right? So about 28 more than would be expected. This one is November. For some strange reason, it's a lot lower than expected.
Mhm.
December, a lot higher than expected. January, higher than expected. But then here, notice that all of these are lower than you would have expected. That tells you is the older players, the ones born later in the year, like October, November, December, you have a better chance, it appears, of being a college baseball player than those born in, say, February, March, April. And the logic behind that, of course, would be that these players born here are a lot younger when they're growing up and playing in these different baseball leagues. And so the older player has a better chance of being successful.
Right.
And so it might not even be talent that plays a role, it's just luck, because you're older on the team, you have access to a better team, you have access to better coaching, and that is what's getting you a better opportunity to play in college baseball.